Hello and greetings to everyone. My name is Sirana John. Today I'm going to present on my final year project entitled Selection of Renewable Energy in Rural Area via Life Cycle Assessment, Analytical Hierarchy Process LCA-AHP, a case study of Tatau, Sarawak. For introduction, 84% of energy in the form of fossil fuels are consumed in 2019 throughout the world. As you can see from the figure above, the primary global energy consumption, renewable energy sources stands at 11%. Carbon emission recently recorded a fourth consecutive all-time high at 33 gigatons of CO2 emission per year, and the government of Malaysia has set a goal of 20% of total generation mix and targets for renewable energy by the year of 2025 in order to mitigate these effects. As you can see from the figures, it shows the 2019 primary global energy consumption and also 2017 primary supply of energy in Malaysia. One of the major issues that happens in developing country is rural electrification. As proven by study by Hanan in 2018, 4% of Sarawak and 15% of Sabah region still have no access to electricity. Some contributing factors to this include uneven terrains due to the geographic factor of the country itself, thick forests, high distribution costs as it requires a lot of cost in order for the electricity to be distributed to the remote area, and also large loss of transmission as the electricity has to undergo fuel resistance in order to reach the remote area itself. Hence, the problem statement in this study are: firstly, unsystematic decision-making method applied in determination of the best renewable energy that can meet the conditions of each unique rural area could hamper a proper rollout of such initiative. Secondly, to implement rural electrification via renewable energy, various factors needs to be taken into consideration, which include environmental, engineering, and economical factor. Next is the application of life cycle assessment, analytical hierarchy process, LCA-AHP method as decision-making tool that would enable a comprehensive evaluation, which includes such factors in consideration. Hence, in this study, Tatau in Bintulu, Sarawak is chosen as case study. The objectives of this study are: first, to determine the contaminants emission and also the cost needed to generate electricity using different renewable energy systems. Second is to determine the environmental impact of electricity generation using different renewable energy systems using life cycle as assessment LCA. And lastly is to evaluate the best renewable energy system in Tatau Sarawak from combined engineering, environmental, and economical perspectives based on analytical hierarchy process AHP method. The scope of this study is focused on the rural area of Tatau Bintulu. As you can see in the slides, the location of Tatau in Sarawak State, which is located in Bintulu district. And also the photo below shows the area view of Tatau Sarawak. The reason behind this place is chosen as the case study is the abundance of potential for renewable energy due to its strategic location for renewable sources, distance to road access, population, and also the land slope. The evaluation was made via life cycle assessment LCA and also analytical hierarchy process AHP integrated method. The criteria in evaluation are engineering, environmental, and economical. Life cycle assessment LCA is used to evaluate the environmental impact of the renewable energy from gate to grave boundary. So next we go to the methodology of the study. First of all, the pollutant emission data from literature sources were extracted for life cycle assessment data LCA. From this, we will obtain two parameters which are acidification potential and also global warming potential. Next, we go to the economical data, which will be simulated using HomoPro simulation software version 3.11.2 to obtain the economical score for each of the alternatives. Next, we go to the engineering criteria, which will be extracted from literature sources. After that, pairwise comparison and relative weight were extracted from literature data in order to obtain the analytical hierarchy process result. Last but not least, The overall priority ranking of the renewable energy systems was synthesized based on the AHP model, which will be shown in the next slide. So for the next part of the methodology, the figure shows the formula and also the unit of measurement for life cycle assessment carried out in the study. So each of the identified environmental potential indexes were evaluated using expressions summarized in the following tables. The main parameters used in the formulas are the mass in kilogram of the specific considered pollutants released to the air, as well as the pollutant specific weighing factor, which are categorized into two, which are global warming potential and also acidification potential, representative of the environmental impact potential per mass unit of the specific considered pollutant. The figure shown the AHP model for this study. The goal of this study is to determine the best renewable energy system for Tatau Bintulu with a functioning unit of 50 megajoule per day, which is the average household usage of electricity for Tatau Bintulu. And the criteria, there are three criteria being evaluated, which are environment, engineering, and economy. The sub-criteria for these criteria are for environment, land requirement, LCA, which are acidification and global warming potential. For engineering, there are three sub-criteria being judged, which are resource availability, efficiency of the system, and technology maturity. For economy, there are two sub-criteria under this criteria, which are capital cost, operating, and management costs. The alternatives that are being evaluated are solar energy, wind energy, biomass energy, and also mini hydro energy. Next, we go to the result of the study. First of all, the environmental result from the LCA assessment. LCA result in figure 1 showed that solar energy emits the most emission for in terms of GWP and AP potential, followed by biomass energy. As indicated in figure 2, the manufacturing of solar energy component contributed to the most of the emission percentage. Next, we go to the next sub-criteria, which is land requirement. Figure 3 showed that biomass energy required the most land area per kilowatt hour with high variability as the biomass source requires large receiving and processing area. Solar energy, in the meanwhile, needed only small area as the components are relatively small in size and does not consume much space compared to other alternatives. For economical criteria, HomoPro simulation software are used in order to obtain the result of economical value for each of the alternative. Electrical load of the case study, which is 50 megajoule per day, are input into the software. Next, the resource data were downloaded from the existing database in order to obtain the latest resource availability in the area itself. Next, component selection are made based on previous projects and literatures, and simulation results were tabulated in order to gain the perfect view of the economical data for each alternative. And overall, as you can see from the figure, solar energy required the highest cost over the simulation lifespan of 1 year, followed by wind energy. This is largely due to the high capital cost of the energy system itself as a result of its high component and equipment costs, which are made from expensive materials. Biomass energy displayed high operational and maintenance costs due to the replacement cost of the electrical generator. For engineering perspective, as shown in figure 5, solar energy leads in terms of its resource availability in Malaysia due to the high solar irradiation of Malaysia throughout the year. In figure 6, the maturity of the technology shows that solar energy is the most reliable and established type of renewable energy in the past. And for figure 7, in terms of the system efficiency, mini hydro energy perform at the highest efficiency as the resource, which is water, is always available the entire time compared to the other resources. Finally, we have come to the overall result of the study. As you can see from the figures, figure 8 shows the criteria relative weight, while figure 9 shows the overall priority weight of the alternatives. In figure 8, it shows the economic criteria ranks top in terms of relative weight and has high variability due to the decline of the price of renewable energy recently as a result of new materials and technologies being discovered. The AHP result in Figure 9 showed that the solar energy is the best renewable energy for Tatau Sarawak. This is largely due to the engineering criteria. The reasons behind this are maturity of the system and also the widely available resource of solar in Malaysia. As for the conclusion, this study has found that economical and also engineering criteria are the most important factors for selecting and ranking these technologies. It is also found that solar energy is the most suitable alternative for Tatau Sarawak, largely due to its engineering superiority compared to the other alternatives in terms of resource availability and also technology maturity. These criteria are found to be imperative as it can reduce the technical and financial risk. However, further research and development can be done in order to discover cheaper and cleaner technologies for solar energy system in order to improve its economical and environmental score. It is also recommended to use analytical hierarchy process AHP based decision model for the formulation of the next national renewable energy policy and development of national and regional renewable energy roadmaps for the country in the future.